Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve a related rates word problem. As per the problem, ship A is 25 kilometers south of ship B and is moving due north at a rate of 5 kilometers per hour. Ship B is moving due east at a rate of 10 kilometers per hour. Find the rate of change of the distance between the two ships 2 hours later. The first step is to draw a diagram for this problem. As per the problem, ship A is 25 kilometers south of ship B. Ship A is moving due north at a rate of 5 kilometers per hour. Ship B is moving due east at a rate of 10 kilometers per hour. We have to find the rate of change of the distance between the two ships 2 hours later. Next, we should draw another diagram for these two ships that shows their position after T hours. In T hours, ship A will travel a distance of 5T. The formula for distance is speed times time. The speed of ship A is 5. So ship A will travel a distance 5T kilometers in T hours. Similarly, ship B will travel a distance 10T kilometers in T hours. We can draw the second diagram like this. So this is the distance ship B travels. Ship A travels 5T kilometers in the north direction. Since ship A was 25 kilometers away from ship B when they started moving, that means this distance between the starting point of ship B and the position of ship A after T hours will be equal to 25 minus 5T kilometers. So after T hours, ship B is at this point, ship A is at this point. We can draw a triangle using the starting position of ship B and the final position of ship A and ship B. The distance between the two ships is represented by this side of the triangle. This is a right angle triangle because north and east directions are perpendicular to each other. So the length of the hypotenuse in this triangle represents the distance between the two ships at time T hours from the starting time. Let's assume the distance between points A and B in this triangle is x. In this problem, we have to find dx over dt. For that, we need to write an equation for x and t. Since this is a right angle triangle, we can use Pythagorean theorem equation to write that equation. In this equation, c represents the length of the hypotenuse. A and B are the lengths of the other two sides of the triangle. We can isolate x by applying square root to both sides. Square of 10t is equal to 100t square. We can keep the other expression 25 minus 5t squared as it is. This is the equation for x. Now we can find dx over dt. For that, we should change the square root to rational exponent 1 over 2. Now we can find the derivative. On the left side, the derivative of x with respect to t is dx over dt. On the right side, we have to use chain rule. The inner function is 100t squared plus 25 minus 5t squared, and the outer function is the exponent 1 over 2. As per chain rule, we start with the derivative of the outer function. We should use power rule. We move the exponent 1 over 2 to the front of the term, and subtract 1 from 1 over 2 times the derivative of the inner function 100t squared plus 25 minus 5t squared. In the first term, 100 is the coefficient of the term, so it will stay as it is. The derivative of t squared with respect to t is 2t. As per the power rule, we move the exponent 2 to the front of the term and subtract 1 from 2 in the exponent, plus we have to use chain rule for the derivative of 25 minus 5t squared. The inner function is 25 minus 5t. The outer function is the exponent 2. We have to start with the derivative of the outer function. We move the exponent 2 to the front of the term and subtract 1 from 2 in the exponent times the derivative of the inner function 25 minus 5t. 25 is a constant, so its derivative is equal to 0, and the derivative of 5t is just 5. Now we can simplify this expression. In the exponent, half minus 1 is negative half. In the next part, 100 times 2 is 200. The exponent on t is 1. T to the power 1 is just equal to t. In the next part, the exponent on 25 minus 5t is just 1. So we ignore the exponent, and 0 minus 5 is negative 5. We have to find the rate of change of the distance between the two ships 2 hours later. So we can sub in t as 2 in this equation and find dx over dt. Two times negative 5 is negative 10. In the first parentheses, 2 square is 4 and 100 times 4 is 400. In the second part, 5 times 2 is 10, 25 minus 10 is 15. 200 times 2 is 400. 5 times 2 is 10, and 25 minus 10 is 15. Fifteen square is 225. 400 plus 225 is 625. 10 times 15 is 150. 400 minus 150 is 250. Next, we can move 625 to the denominator to make its exponent positive. (625) to the power half is equivalent to square root of 625. Square root of 625 is equal to 25. 25 times 2 is 50. Therefore, dx over dt at 2 hours is equal to 5. And the unit is kilometers per hour, because that's the given unit of speed. This should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.